Hey, and welcome to Making AI Tanks Fire. In this video, what we're going to do is we're going to limit the firing rate down to 1 every 3 to 5 seconds, whatever we set, and also make sure that these AI tanks can fire at us. So it'll become a bit more of a game in the process. So see you in there. So we're back to that age-old question, what's the least fun thing about this game? Well, lots of things need improving, but I would say the least fun thing is there is zero challenge right now. We can just pick these other tanks off like sitting ducks, quite literally, because they can't fire back. So let's focus our attention on having them fire back for now. Remember that we're running an iterative cycle. We've just been working on the controls of our tank. Now we're just going to move on to thinking about improving player 2, and we'll be back to work on controls and aiming and lots of other things later. So, how are we going to do that? Well, I want the AI tanks to fire. So let's go and have a look at our code and think about where that would happen. It would happen in the tank AI controller. Now, in this tank AI controller, we actually have a couple of very thin methods here. One gets the control tank and one gets the player tank. Now, if we go and look at the header code for this, you'll notice that these getters are actually private getters. And that's probably a bit of a warning sign that maybe we've done a bit too much refactoring here. So thank you to those of you who pointed out that possibly we've gone overboard with the creation of methods. If these getters aren't even needed from the outside, i.e. they're not in the public interface, then why do we necessarily need separate methods for them? I would argue we don't. So as part of this making this tank fire, let's go ahead and make it work as we are to start with, and then I will ask you to do a defactor and the opposite of a refactor. So firstly, let's just make the fire work. So let's use the existing clunky get controlled tank method, and then we can just say fire. Now remember that it just fires where the barrel is currently pointing. So this is going to fire every single frame. It's not fire if ready, but it's fire every frame. So I'll get rid of the comment, and let's just try building that and see what comic effect we get from that. And then we will get you to do some defactoring, because knowing how to refactor code and to factor out methods is hugely important to extract functions, but doing the opposite sometimes is an equally important skill. Look at this, hose pipes of projectiles there. Look, it's crazy. There's actually almost a little bit of challenge now, because we have to aim and hit these tanks before they do that to us. What a load of fun. So we have achieved our aim of having the tanks fire every single frame. What I want you to do now is get rid of these two methods and to put it all inside the tick method as neatly as you can. So here's your challenge. Inline the two private getters. Remove the two methods. It's called inlining or defactoring. Put the code in the tick method. You can remove the code in begin play as well, by the way. We don't need that anymore, those checks. So go ahead, pause the video and see if you can inline the code now. If you're not sure what I'm talking about, I'm literally just saying remove those two methods and do what they do as simply and cleanly as possible inside the tick method. Okay, welcome back. So the way that I'm going to attack this is I'm going to firstly delete this code at the top. We don't need to check about controllers possessing tanks. It seems to be working most of the time, and we're not having any issues with that. So if get player tank, well, instead of get player tank, this is getting the player tank, this thing here. So what I'm going to say is auto. Now we'll talk about why we do this every frame in a second. Auto player tank equals that stuff. Now, be careful, because previously it was a player pawn and then it cast to a tank. So let's do the cast all in one go. Player tank is the result of going and finding the first player controller's pawn and casting it to a tank. Cool. So that does everything this does apart from the protecting of the player tank pointer. But we can do that right here. We already kind of were. If player tank. Now, if you look at it, we've got the cast, we've got the get, and we've got the pointer protection. We don't need get player tank anymore at all. And in the header file, we can get rid of the declaration. Fantastic. Okay, so what next? Get control tank. Well, that's even thinner. So let's take a look at that, and we can say auto controlled tank. Or it could be AI tank, I guess, but we're inside the tank AI controller, so I think control tank is more meaningful. And just that. Now that's all that method did, so we can get rid of it. Now make sure you've got rid of your code in begin play, because that was calling these methods too. Let's remove get control tank. We've lost quite a few lines of code here for the same behavior, and losing lines of code and ending up with the same behavior is generally a good thing. So we're nearly there. These two lines need to change. So instead of get controlled tank, etc., I'm just going to write the new line above it. Control tank, aim at, and then player tank. Now we're nearly there, and then you look through the player tank pointer and say get actor location. And I think that looks absolutely fine. The control tank should aim at the player tank's location. Almost reads in English. Perfect. Same thing here. Instead of get control tank, it is just control tank, fire. And then there is going to be a to-do here. To-do, don't fire every frame. So we need to limit, or more specifically, we need to limit firing rate. We need to do that later, but for now, let's stay focused on one job at a time. It was to defactor this code like this. So let's go ahead and compile and see how this behaves. Oh, we love waiting for compilation to happen. Resist the urge to fill this with filler. Oh, I just did. Okay, so here we go. Let's see what happens. It still works. I can still fire. Oh, and that's pretty good. Okay, fantastic. So we have what we were looking for, which is a simpler way of doing this, and also the AI tanks are firing now, which is great. So we need to be limiting the firing rate as a next port of call. So let's think about that really quickly. It's in the tank that we would be limiting the fire rate, and what we would want in the tank is something like a float called reload time in seconds, and we could make that 3 seconds. All right, so I'm going to make a float on the tank called reload time in seconds. Then remember that the AI controller, both the tank and us, just call this fire method. Well, let's go look at the tank's fire method. This tank's fire method currently just fires regardless. But how about if we didn't just fire regardless? How about if we were to set a timer and then only fire if that timer had expired, basically? So the way that I'd be doing that is a Boolean for is reloaded, and it's going to be equal to. Now, I'm going to introduce you to a new, more precise world timer. Instead of get world, get time seconds, we can also use f platform time seconds. Now that actually returns a double. Now let's imagine we have something called last fire time, a member variable, which we don't. Well, if this subtraction is greater than the reload time in seconds, then that means that we are reloaded. So let's make ourselves a last fire time. Double, last fire time, starts off equaling 0. So we're assuming that we've effectively fired at time equals 0. So this does mean that our first shot won't be able to happen for 3 seconds. But that's fine. So we have this Boolean, is reloaded. Okay, now I'm going to change the logic around. Instead of saying if not barrel return, I'm going to say if, pull all of this into the if, sort out my curly braces, then say if barrel and is reloaded. So if we have a barrel and we're reloaded, then spawn a projectile, fire it off, and then reset this last fire time to the platform time seconds, remembering that these things are doubles. Okay, when I declare and actually initialize the value of last fire time to 0 here, it will be a double automatically in C#, by the way. If you don't say F for float, then you get a double. But in this case, this thing will be a float because we've explicitly said it's going to be a float here, and this 0 here will be interpreted as a double, not only because we've said double, because actually that's the default behavior in C++. Let's see if this reload timer works. Take a look at this code, make sure you're happy with that reload timer. And then let's compile. And the idea here is we'll have a limited firing speed, which we'll then be able to set. Later on, I'll show you how to set it in the inspector. But we're not going to do that right now. We're not just going to slap an edit anywhere on it, because I'm fed up with using that. I want to start showing you some alternatives. So this is pretty cool. Look, I can fire, boom, and I can't fire, can't fire, can't fire, and then suddenly I can fire. And it's the same with the AI tank. So it's becoming somewhat more of an actual game now. Things are happening. Okay. Great, so well done getting this far in this video, and I will see you in the next one.